Topic 8, transformations. A little overview before we go into the main lesson. So what a transformation is we're going to get an image and we're going to move it. So we could either reflect it across the thing, we could just move it, like slide it, or we could rotate it. That's what transformation is. We're going to take that same image and we're just going to move it to a different spot. That's a transformation. The image that we start off with is called so this will be the pre-image. Let's label it ABC. Then after you move it, you call it the image. So this guy over here, let's say we move this guy, so we call it the image. And when we do the image, that's the one that's been moved. So we usually put a little prime on all the things. So let's know that's the image. That's the one we moved. So the original one is ABC. After you move it, we'll put a little prime on there to let us know this is the one we moved. So what we do is we do rigid motions. The transformation where the pre-image and image are the exact same. Notice, right? They're the exact same. They're the exact same size and shape. All we're going to do is change the location. And we're going to do that by either doing a reflection, translation, or rotation. That's considered a rigid motion. So you don't change the shape or size of it. You just move it. It's called a rigid motion. So first one is a reflection. So what happens there is we flip each point across a line, either an x-axis, a y-axis, or any given line to do it. So like in this case, this is a horizontal flip. Right, we're going to flip this horizontally like that. So we'll flip this across like the y-axis. And you go from here to here. Right, you can also flip it vertically like that. Or you can flip it across any line like this. Right, so that's a reflection. You flip it across the line. Next one's a translation. So you're just going to kind of like slide it. You're going to move it. So we're going to slide this guy over there. So if this is our image, ABC, this will be if that's our pre-image, this will be our image, A prime, B prime, C prime. So we're just going to move it. And you can even slide it down. So you can slide it horizontally. You can slide it vertically. Or you could do it like a diagonal. Right, so you move it horizontally and vertically. That's what this one does. That's a diagonal slide. Or you could rotate it. So when you rotate, you kind of like turn the image. So here, like we see this as our original image, a pre-image, and it looks like we're rotating it right here, and we're like rotating it that way. So you could say you could rotate it that way, 90 degrees, clockwise. Right, clockwise means it moves like a clock. So if you think about a clock like this, right, clockwise goes this way. So rotating it this way. So if you see this and we rotate it like this way, that's clockwise. So it's like a 90-degree turn clockwise. If you want to, you can also go backwards this way, and that'd be counterclockwise. This would be 270 counterclockwise. Right, so it's the same thing. And you can look at something like here, right? Let's say this is my original image. Let's do this one as original image, or pre-image. Right, and then this one looks like you could do it clockwise. I would say about 180, right? Or you could do counterclockwise 180. Either way works. Or counterclockwise. And you can see here, this one does, it looks like right there's our center rotation, and we can go all the way around. So right here would be this would be about 270 clockwise. Right? It's like almost a full circle, but like a little back 90 degrees. Or you could say negative 90 degrees counterclockwise. But again, we'll spend a whole like lesson on this. It's just a general idea of what things we could do. We could do a reflection, we could do a translation, we could do a rotation. And all these are considered a rigid motion because they don't change the size or the shape of the figure. So it's a non-rigid motion, something that changes the size or the shape. So dilation is a good example because dilation changes the shape. So you go from like A, B, C to something that's like twice as big. A prime, B prime, C prime. So dilation is a good example of a non-rigid motion, right? Changes the size or shape of it. So what we're going to focus on in this chapter, this topic, is rigid motions, things that don't change the size or shape. So we're gonna reflect it, translate it, or rotate it. It keeps the shape the way it is. And our first one that we're gonna focus on is reflections. So again, with the reflection, we're gonna reflect all the points across either the x-axis, the y-axis, or some other line. We'll reflect across that line to get a new image. It'll be the same image, same size and shape, just reflected, just moved to a different place. So let's start by plotting our points. A -6, -6, 7 is right there. That's my A. B is -6, 1, right there. C is -2, 1, so -2, 1. There's my C. Let's connect those points. And like that. Now we want to reflect it across the x-axis. So the x-axis is this line right there. Right? So we're going to flip it across that guy. Like that. So let's do this. I'm going to do it in blue, I guess. So all we're going to do is we'll go the same distance away. So we want to reflect it down. So this is 1 away, 1 up from -6. So we're going to go 1 down from -6. That'll be my new B. Now let's keep a running tally here. Let me write our normal points. These are our pre-image. We have -6 and 7. We have -6 and 1. And we have -2 and 1. Now we're going to have our image, right? After we change it. So A prime, B prime, C prime. So our new B is at -6 and -1. My new C, we're going to go the same distance but down. Like from here, we're going to go the same distance, right? So it was up 1, now I have to go down 1. That's my new C, and my new C looks like it's at -2, -1. Then we're going to do the same thing for our new A, right? So it's at -6, we're going to go up 7, so we just have to go the same thing but down 7. So right there. That's my new A, little primes. Right, so that's the way you do a reflection. You go, okay, how far is it from the line? And then do the same thing across the reflection. So 1 up, 1 down. Oh, it's 1 up, so we go 1 down. It's 7 up, we go 7 down. If we connect it, we reflect it across the line, like that. All right, perfect reflection across that line. So next is that, oops, I forgot my last point. Can we glean anything off of this? Look at this. What happens when we reflect it across the x-axis? What happens to the points? Right, the x's are the same, but the y's change. They go from positive to negative. We change the signs of the y's. So the rule for reflection across the y-axis or the x-axis is, let's get that rule. Reflection across the y-axis, the x-axis is xy turns into x negative y. Right, so that's our rule. So we reflect across the x-axis, we're just going to change the y's. So we can use that here if I also want to graph this guy. Right, so we could either go, okay, it's across the x-axis, so figure out how far down and do the same thing up. So at 2, we go down 3, so we're going to go up 3. At C, we're going to go down 6, we're going to move it as x up 6, right? That's how you reflect across the x-axis. Or you can use the rule. So, and the rule is you look at these points, and all we're going to do is change the y-axis. So, in this case, -3 turns into 3. B, 6 -1 turns into 6 1. And then C, 5 -6 turns into 5 6. Right? It works the same way. And then 5 6. And if we connect these points, we have our new graph. Don't forget to label it A prime, C prime, and B prime. So that's how you reflect across the x-axis, right? You change all the y's. Now let's do the same thing for across the y-axis. So this one we're going to do the same thing, but you want to reflect across the y-axis. So we're going to reflect it across here this time. So we're going to use the exact same concept. If you want to reflect across there, just go to that where you find C, right? So it's up into the left one. So we're just going to go up into the right one. We want to reflect across this guy. So just figure out where that matches and go the opposite distance away. Right, so then over here at 1, B is 5 away. So we're going to go back to 1 and go 5 the opposite direction. And then the same thing with A, right? So A is 6, at 6, A is 5 away also. And then we're gonna go 5 the opposite direction. I feel like that one might be, a point might be off. Okay, so like that. I think this one was 5, 5. Okay, whatever. So you get something that looks like this. Like that. And if we look at our new points, so we went from, so we have points like this now. And look at our new points compared to our old points, right? So this is A prime, B prime, C prime. A prime is 5, 6. B prime is 5, 1. And then C prime is 1, 2. If you notice what happened this time, when we flip it across the y-axis, we changed all the x values this time. So the rule here is if you want to do a reflection across the y-axis, we're going to go from xy in our pre-image to negative xy. Again, that just means change the sign. If it's negative, change to positive. If it's positive, change to negative. So that's the rule. Again, it might just be easier to go, okay, how far is it apart? Move it there. How far is it apart? Move it there. But that is the rule if you want to use the rule. We'll skip down for time. Same idea, right? Okay, let's try something interesting. Let's flip it across the line y equals x. So we want to flip it across the y equals x line. So y equals x would be, right, plus 0. We start at 0, go up 1 over 1. So that's going to be kind of like this. That's my y equals x line. And that's what we want to flip it across. So how are we going to do with this one when it's a diagonal? Well, the same concept, right? So let's start with the C here. You want to see how far it is from the line. So what the difference is, you want to go diagonally. Or over here, we went like, it was easy because it was vertical. You just went up, down 1, down 4. So you just go up 4, right? Down 7, so you go up 7. On the diagonal, you got to go diagonal. So the diagonal to this line, it's going to be 1.5. So we're just going to do the same thing on the opposite end. So half and then 1. So right there. That's my new C. All right, we're going to do the same thing with the A. Right, we're going to go down the diagonal. So that's 1 diagonal, 2, 3, 4, 5. So 5 diagonals this way. And then do the same thing on the opposite end. So 1, 2, 3, 4, 5. So there's my new A. I'm going to do the same thing with our B. So there's 1 diagonal, 2, 3, 3.5. Right, and then we're going to do the same thing on this side of it. So there's my half, then 1, 2, 3. And then this guy is the reflection across that line. Now let's see if we can figure out anything about this one also, right? So this point here is 6, negative 4. This one is 1, negative 2. And then this one is 1, negative 7. So let's put them next to each other, right? So A is now 6, negative 4. B prime, right, is 1, negative 6. I can't count. Sorry. So now it's 1, negative 6. And then C is 1, negative 2. Look at the difference between what the image we started with and the image we got. Notice the difference here? They transpose the numbers, right? They switched them. So X and Y get switched. That's the rule for doing it this one. So the rule for if you want to reflect across the Y equals X line is your image XY turns into, or your pre-image XY turns into the image YX. So this is the pre-image, right? That's where you start. And then you end with the image. Right, and actually this is probably the one where I think it's the easiest to actually just, instead of figuring out the rest, it's just doing the math on this one. Right, so here's my picture. And if I want to do the reflection across the Y equals X line, which is again, that this line here is this line there. Right, I actually think this is easier to do it by the math way. So we're just gonna switch it. Right, that's all we have to do is flip the numbers. And then plot our new numbers. So negative 3, 2, negative 1, 6, negative 6, 5. And then we get a graph that looks like this, right? Where that is A prime, B prime, and C prime. Right? Or it might have 3 negative. I think I have these two switched. I was doing so well. A prime, B prime, and C prime. There we go. So I think for reflecting across the y equals x line, that's actually easier to do. When you do some of the flipping across the x and y, it's just as easy to go. Instead of doing the math on it where you have to switch all the x's or all the y's, just going, okay, reflecting across the y-axis, that is this guy. So all we gotta do is count from, okay, this guy is here, it's 4 away, so let's go 4 the opposite way. All right, this guy is right there, so that is 4 this way. That's 6 this way, let's go 6 the opposite way. And then down here, right, we are 2 away from the y-axis where we're trying to rotate again, so we gotta go 2 the opposite way. So right there. So you get a graph that looks like that. Right. So for me, that one's just as easy to do, just by like looking at it. Just by going, okay, I want to flip it across this y line, just figure out how far apart each point is. While when you flip it across y equals x line, I think that one's easier to just transpose the numbers if you remember the rule. Anyway, that's the lesson.